Dylan, maybe you should introduce yourself first.
Yeah, I'm Robert Dillon, and this is Titans of Nuclear. Today we're going to turn the tables on Bret and ask him about the two new projects he's launching.
Awesome.
On this episode. So, Bret, you want to start by telling us about OPEN100 and Last Energy?
Yeah, I'd love to. So for all of our devoted listeners out there, sorry that we've been off the air for the last couple months. I promise we'll come back with new episodes soon. But we've been working hard. As you probably know, Energy Impact Center, which hosts the Titans of Nuclear podcast, is a broader organization. And over the last year, we've been investing in techno-economic analysis of nuclear power plants, trying to really understand what's been going right and wrong over these last 50 years. And the OPEN100 project, which we're announcing today, is the culmination of that research and our path to take the nuclear industry into the next generation of growth.
Great. So, you've made it your mission to come up with practical and achievable solutions to climate change. You've spent the last 2 years doing interviews, building this podcast up with interviews all around the world of nuclear experts. What did you learn in that time?
Yeah. I mean, it's been awesome. We've traveled the world, right? Over the last couple of years, we've been to over a dozen countries and like 100 different sites, whether they be labs or power plants themselves. I mean, it's been truly amazing. And I came into this without really any knowledge about what nuclear energy is to begin with. But we asked a lot of questions, and a common theme that we kept hearing over and over and over again was cost. The economics is what's holding back nuclear industry's growth. And it makes sense too. When I first got into the space, I thought maybe the issues were public perception or safety or waste or weapons, and none of those panned out. None of that was holding back the industry. It was just cost. And so when we set out our eyes on really trying to drive impact in this space, right? Energy Impact Center, that's our goal, to drive impact. We thought to focus on the cost question. And that's what we've done. We've looked back through historical examples of nuclear project deployment successes, and we've looked at examples that weren't successes, right? Yeah, throughout the 80s, there were a lot of cost overruns. Current projects today are struggling. Even projects around the world, in Finland and just all over, there are real issues with getting these projects done in a timely manner, and that timeliness, right? That's related to cost too, because the longer that these projects go on for, the longer you're borrowing money. It's incredible. The first fact that really just totally shocked me about the cost equation was that half of the cost of the power that comes out of one of these newer power plants that takes 10 years to build, or in some cases 20 years to build, half of the cost of your electricity was just the interest on the financing charges during that construction period. That's crazy. And so we knew that if we were going to address this cost issue, projects being deployed in a time-efficient manner, expeditiously, was going to be a critical factor to success.
So what is the solution to the time problem and these cost overruns? What have you come up with that is going to move the ball forward, you think?
Yeah, well, one of the things that we love all of these ideas about we've heard about modularity, and we've heard about new seismic technologies and automation. We love these ideas. We think they're amazing, but they don't necessarily address the construction time equation, right? And then if you look at other industries, other comparable industries, they can build big infrastructure projects in 18 months. Hell, I live in Washington, D.C., and just around the corner, there's like 5 different buildings that are 12 stories each, going to have like 300 units in them. And these things get done in just about a year. So you can pour a lot of concrete, lay a lot of pipe, install a lot of electrical work in a very short time period. But what do these projects do right, and what has the nuclear industry done wrong? One of the things that we've seen them doing wrong are, in the industry, it's often referred to as first of a kind, right? Well, what makes something first of a kind, right? It's deviating from where the industry has experience. It doesn't necessarily mean new technology. Right. It's just a deviation in general. And so if you want to address the construction time question appropriately, what you have to do is work with the construction industry and look at what they do right and also what they do wrong. Right? We've got a lot of negative examples too. Bridges taking, 5-10 years too late. A lot of this comes down to project management. Some of it comes to size, right? The minute you hit that $1 billion threshold, boy, I don't care what your project is, it's going to run over time and over budget. So you've got to keep it small, and you've got to keep it to standard construction practices. That's some of the key insight here. Sorry, it's not sexy. It's not as sexy as a new reactor, I'm sorry, but that's critical.
Right. The key is to be able to standardize the building process so that there's not a lot of unexpected things. There's not a lot of new engineering that has to be done then.
That's right. Like, it's tough, right? Because, I came from outside the industry, but now I'm proud to be part of the nuclear industry. And I'd love to cheer the successes, when I see, these construction projects, whether they be Vogtle or whether they be, Hinkley Point in the UK, and you see this awesome, massive equipment, capping off the containment dome, or moving a steam generator in place. Like, that's awesome, right? It gives you a cool, I'm an engineer, cool feeling. But then I have to remind myself, no, this is what is sinking these projects. When you see a crane that is the largest crane in the world, that is a sign that your project is a failure, not a success, because you have deviated from standard construction practices.
Yeah, there's extra cost to build that crane, to get it into place, to use it, and then, is it ever going to be used again? Right. Or is that just your cost?
And what if something goes wrong with it, right? What if something goes wrong with it and you need to wait for a specialty part to be machined from Germany and then shipped in, and you've got 6,000, or God, in some cases 9,000 construction workers on site that are delayed now? I mean, that's expensive.
Right.
So no, the key is, like my high school physics teacher always told me, keep it simple, stupid.
Yeah. Yeah, I think that's something everybody can relate to, right? So, but going back to OPEN100, then, all right. So you've taken this lesson. How have you applied it, and how did it come about to be OPEN100, and what exactly does it offer?
Yeah. So there are 3 components to the OPEN100 project, and the OPEN100 project, to summarize it, is a template for new nuclear power plant deployment. And the 3 key components are: 1, engineering files, okay, literal engineering schematics, 3D files, 2D line drawings that constructors, that engineering firms can actually use to actually build something. A full suite of engineering files. That's just part 1.
Yeah.
Part 2 is a construction sequence. Here's how long we think each piece of the construction process should take, as mirrored off of other comparable examples, let's say in building a combined cycle gas plant, right? How long should this take for a comparable construction project, and mapping out the time and the construction costs. So that's part 2, the construction sequence. And part 3 is an economic workbook of the whole project. So line item, every component to the project, whether it's an engineering subsystem, how much do we think this piece of equipment should cost, all the way through to what do we anticipate the interest charges to be on that capital that you borrowed. And so full economic workbook we're going to be publishing along this as well. Now, keep in mind, this is a living project, right? So we're publishing all this, and then we're going to be collecting feedback. We're going to be refining it. But this is a starting point to show anyone who knows anything about the industry, this can be built at this cost in this time. And they should either be able to say, yes, I can do this, and I'm going to deliver clean energy to my people, to my ratepayers, to my taxpayers, or they should be able to tell us, no, we can't do this, and here's why, and then we're going to use that information to refine the models.
Right, and so that's where you get the open, right? The open, like open source, like coding, taking that example from the technology, the computer sector, and allowing others to contribute to the code, to the program.
That's right. Transparency is key to this. Perhaps this falls out of the disposition of our organization, which is we're a research organization built for public good. Right. The mission of the Energy Impact Center is to reverse climate change in 20 years. Hands down. Stop. End of story. That's the mission. And so, making something open source definitely fits into that thesis. But it also happens to solve a lot of the challenges in this industry, where these proprietary, complex designs in a niche industry where you only build one thing, per country, per decade, when you keep things private, when you keep things locked up, what you're doing is you're creating a situation where you're going to run over budget, you're going to run over time, because there just aren't enough people looking at it and keeping things in line. And so we're really setting out to solve a couple different challenges here by open sourcing it itself.
So why hasn't this been open before? Why, or standardized even?
That's a good question. I mean, why hasn't things been standardized? Some industries get standardized, some don't. And I think what we do, when we see big things getting built, the successes are where things get standardized. And then, of course, when things don't, that's when we see things run over cost and over schedule. I think maybe comparable where things haven't gotten standardized yet to a certain extent is like the tunnel boring industry, where they keep building new tunnel boring machines, the Big Dig in Boston or in Seattle, and each one is bigger and newer and more complex than the last one. And then once again, you see these things cost like what, like $1 billion a mile or something, or maybe even more, I think. So I think I can't maybe speak to everyone's motives as to why this has happened or why this hasn't happened historically. But I'll tell you what, it's happening now, and the standardization is going to be what saves the industry.
Two things here that strike me. One is that these are projects that are unique a lot of times and were, kind of developed on the engineering board and not the commercial sector. There's not this, like in the oil and gas sector, right? In the shale sector, there are companies that all they do is bore the well hole, right? The oil company may own the lease, but it's another guy that comes in and drills, and he's a specialist in drilling, right? And he invests in the capital, and he takes that rig out, and he makes money off it, right? So he's got an incentive to innovate, to be more efficient, to figure out how to do the process right. On these bigger projects, the engineer comes up with it, says this is going to solve a problem, but there's not a sector that's going to grow around that that can kind of test that in the real world over and over and over again, right? The other thing here is that in the U.S. anyway, in the utility sector and these big projects, it's a monopoly system. It's a government-regulated system, and the cost payback is based on capacity markets. So you build a utility says we need this much electricity. We're going to build a nuclear plant. We're going to justify the size and everything. We're going to go to the regulator. If the government approves it, it doesn't matter what it costs us because we're guaranteed those costs plus a profit margin. And the people that pay are the public. Right? So if you're a private company, you care about what that price is. If you're a government entity or a government regulated entity, you don't always care. Right? So that's two things that I can see that have been challenges.
And so you're absolutely right. We think that the way that these projects are financed also presents a great challenge. Like, I get it, and I'm very sympathetic towards the individuals at these organizations who are just trying to get a power plant built. And they're looking at their options, and whether it's the EPR or the AP1000, and it's looking like it's going to be a $5 to $10 billion effort. There's just no way to privately finance it, and so they have to go to the government and they have to say, "Listen, we need help. We need to fix the rates. We need loan support." Like, I get it, and I'm sympathetic, but that is not what is going to create a scalable industry that is going to replace all fossil fuels on planet Earth and solve climate change. Okay, there needs to be another model. There needs to be a privately financed turnkey style model. We've seen this in little fits and spurts here in the past. We see this in other industries for sure, but that's what we need to bring the industry back towards. And so we're also spinning off our second announcement. We're spinning off a private company, Last Energy, that is going to help with that private financing of new nuclear power plant deployments.
So you're going to evaluate projects and decide whether to invest or not?
We're going to act as an intermediary between capital markets in the U.S. and international development opportunities abroad.
Okay. One of the things, just to back up one step, is, it sounds like you're almost either revitalizing or creating a new industry around, the standardization building of a nuclear power reactor, right?
Yeah.
Because, as we said, these have been one-off projects. And if you can create that kind of driller mentality where you're a service sector, vendor, we pour the concrete, or we build power plants based on this plan. And what's your time period? 2 years, 3 years or under?
For the OPEN100 project?
For on a construction project.
We think there's no reason that it can't be done in under 2 years, 24 months. Industry standard for comparable projects is 18 months. And that's what we're doing. We are making sure that the industry gets in line with best practices and standard construction methods.
And this isn't just domestically, right? You're looking at this possibly being international and worldwide.
We think probably it's going to start off international. We're not sure where these are going to get developed first yet, but most energy growth is happening globally, not domestically. And carbon is a global problem too. It's not just a U.S. problem. So, from the organization's outset, we've always thought of this as a global problem to solve, and our actions are going to reflect that moving forward.
One of the things on that you talk about is the need that, net zero isn't good enough.
Yeah.
And, as you said, if emissions are reduced, in Asia or in Europe or in Africa, that's, just as good as reducing them anywhere else, right? But can you tell me a little bit more about your concept of net negative?
Yeah.
And what needs to be done and what it really means and how we get there?
Yeah, so I talk a lot about this in the lectures that I give at universities across the country and really across the world, and you can find me talk about this topic ad nauseum for hours at a time on YouTube if you just Google my name. But in short, the concept is it is not enough to just eliminate all new emissions. We've already put a ton of carbon in the air. It's that carbon in the air that has a net radiative forcing, right? A net addition of heat, whether you don't add any new emissions or not. So what we need to do is we need to be able to pull carbon from the air. Now, if you can pull carbon from the air, that also helps you effectively decarbonize a lot of other hard to decarbonize sectors as well, even if you were just getting to net zero. But no, the problem is to get to net negative, remove the 1,000 gigatons of CO2 that we've added to the air over the last 200 years, and in order to do that, you need an extremely abundant, extremely energy dense, right, which means low carbon footprint, energy source to enable that direct air capture of our legacy emissions. And nuclear, via the laws of physics itself, is the only one that can satisfy those requirements.
Now, when you started this 2 years ago, did you start with the idea that you were exploring nuclear, or were you just exploring decarbonization options? We're
just exploring how do we fight climate change to begin with. Now, since then, actually, this is tough, but I almost have come to believe that energy poverty is a bigger problem than climate change. And so in a certain sense, we've broadened our mission there as well. But no, didn't know anything about nuclear. I hadn't spoken to or met a single nuclear engineer in my life 2 years ago. But now that I know about half the community and have been, analyzing them under a microscope, we feel really well positioned to take on this challenge.
One of the things about, nuclear power plants is their size, right? So you've got to, they don't fit everywhere. They don't meet every market demand. And they're constantly creating energy, right? So one of the things about OPEN100 that's interesting is the different sizing to fit the market. Can you talk a little bit about that? Because especially if you're addressing energy poverty, in parts of the world where energy demand is not that high now, maybe because, unfortunately they're still using very crude forms of energy, sometimes just burning wood or, worse than wood. That energy demand in those areas is going to grow. as they become more affluent and as they get more access to energy. But right now, there's a low energy usage and demand. So how do you fit that into OPEN100 and the design?
Yeah, so well, I'll start off by saying OPEN100. The 100 has a dual meaning, but one of those meanings is 100 megawatts of electricity output. And so that is what we have deemed to be the appropriate size to fit within your standard construction practices, but also to fit within existing infrastructure, electrical grid constraints as well. Now, I would actually push back on that claim you made. I think that the energy demand, virtually anywhere you go, any country in the world, well, it's not like an island nation, the energy demand is already big enough to support big power plants. The problem is the grid. The grid can't support it. And that's why there's this whole talk about decentralization, and that being some of the advantages of these smaller power sources, that you can distribute them. And that is somewhat true. And so, at 100 megawatts output, you could put it outside of any city that had about, let's say, 100,000 people. That's a good rule of thumb. And give them the energy that they need to live a prosperous lifestyle, and work around some of these, as you rightly pointed out, infrastructure constraints of the developing world.
Now, so at 100 megawatts, that's about a tenth of the current size of the big light water reactors.
Yeah, sure makes math easy, doesn't it? Just divide everything by 10.
I do like tens.
Yeah.
That gets a lot easier to do than anything else. All right. So actually, that brings me to my next question. When we talked about, when people talk about decarbonization, they're talking primarily about the power sector and the transportation sector. I don't think a lot of people really encompass what the global economy, all the sectors means. But the challenges are the manufacturing and the heavy industrial, right? How you make steel, how you make those products, right? They're very energy intensive and stuff. And when a lot of the time when climate activists or climate alarmists talk about this solution, the solution is, well, we're just going to reorganize the economy. Those jobs are just going to go away.
Right?
Right. Well, and then, so the immediate reaction is the people that work in these industries are, they recoil, right? And I think a lot of people kind of freeze up. They're like, well, it's too big of a problem.
Yeah, it just doesn't seem realistic. If you're going to say, we need every part of the modern economy, we need a solution to replace it all within the next few years. I actually don't think people get paralyzed by it. I think people just ignore it because it's almost too wild a proposition. It just doesn't seem realistic. Things just don't transition that quickly. I mean, come on, we're still driving the internal combustion engine, 100 years later. There's a reason. Yeah.
We were promised during the nuclear age that we were going to have jet powers. So I'm still waiting.
Yeah. So one of the amazing, once again, coming back to just these amazing things that we learned about nuclear energy in our discovery process, is it's essentially one-for-one replacement for about 60 to 70% of carbon emissions, right? You can satisfy electricity with it. You can satisfy building heat with it. You can satisfy many industrial processes with it as well, by just using the heat that comes out of a nuclear reactor, not necessarily the electricity. Now, here's what's pretty amazing. This would be about any energy source. If you can make it low carbon enough and cheap enough, you can essentially replace all fossil fuels by building your own synthetic fuels from scratch, right? One could literally pull CO2 from the air, pull water vapor from the air, and then take the hydrogens from the water and take the carbon atoms from the CO2 and reconstitute any fuel that you need. So that's an immediate way to decarbonize the entire transportation sector. Now, granted, if you're going to do that, pull it from the air, turn it into synthetic fuels, that's a very energy inefficient process. But if it's carbon free and you've got abundant energy, who cares? The math works. Let's do it.
And now, has that process been done? Because that's, that's a startling revelation to me as well.
Yeah.
Right.
No, it seems out there, right?
Right.
And most people would just ignore it because it violates the first constraint that people look at. We don't have a carbon-free energy source that is scalable, abundant, and cheap enough. But that cheap enough, right?
Right.
That's what we're changing. right? If we can make nuclear cheap enough, all of a sudden, all of these amazing new strategies for decarbonizing the transportation sector don't seem so out there anymore. To answer your question, has it been done? Yes, the physical processes have been done, namely on nuclear-powered aircraft carriers, where the Navy wanted to see how they could make jet fuel at sea using just what's out there at sea and that amazing abundant energy source. So this whole process has been done, but not at commercial scale.
Right.
But once again, if you can solve that cost equation, right? If you can make nuclear energy cheap enough, anything's possible.
And what kind of feedback have you gotten so far?
So all of this whole I really have to give it to the nuclear community. Although the nuclear community seems old and stuck in its ways, everything that we have learned is from meeting with the nuclear industry and having them help us understand what the problems have been, what's gone right, what's gone wrong. So this project is almost like the birth of these conversations themselves with full industry support. We're going to be partnering up with the national labs, not just here in the US, but abroad as well. Industry partners, vendors, technology startups, you name it. Any stakeholder that sees the opportunity to bringing cheap, clean electrons to the world can be part of this project.
What's the timeline? What's the the horizon for this? When would you like to have the first plant built?
So we launched today. The construction schedule we have laid out is for less than 24 months. And so, if theoretically, it would be possible to have a new nuclear power plant built in 24 months if all the stars aligned. In reality, I've run a business before. It takes a little while to actually get all the contracts in place. But once we find an interested developer, putting together the capital for something this size, $300 million, that's no big deal. You could imagine seeing one of these things turning electrons onto the grid, I'd say easily in less than 3 years.
Quite a challenge. All right. Well, we'll be back.
Yeah.
See how it's going.
Great.
Anything else you want to say?
No, just a quick thank you to, not just the guests that have been on the show for the last 250 episodes. And once again, I promise there'll be more coming soon. But also you, the audience, for writing in, helping us answer questions, making guest suggestions. We could not have done it without you. And I cannot tell you how much I appreciate your support.
Great. Thank you very much.
Thank you.